Now this is a fairly generic type of consumer unit, and this probably applies only to the UK because of course other countries have different arrangements. Now this is the sort of thing that you can buy, and it already comes with various devices installed inside. Typically these are sold cheaply in DIY sheds and the like, but nevertheless this does seem to be the one which gets installed in the majority of properties. This particular one is fairly small. We've only got 6 circuits here, so 3 there and 3 there. But this sort of arrangement you can get in with a larger number of circuits, quite often sort of 6 on each side for a total of 12. And I personally don't like this arrangement of devices, but nevertheless this seems to be the most common type which seems to get fitted. And what we've got here basically is a main switch, which as the name implies just switches the whole thing on and off, so on in that position there and off there. And this is just a switch, it doesn't have any overload or anything capacity. Rated to 100 amps, which is fairly typical, but say it's not actually going to trip if you exceed that. That's simply the maximum that it's actually rated for. And then we have 2 RCDs, or residual current devices, one here and one here. And these are the things which will trip when there's an imbalance between the line and neutral. So, for example, if the current is going somewhere that it shouldn't. These ones in here are both 63 amps, which is the maximum current they can accept, not the actual tripping current or anything. And the tripping on this one is 30 milliamps, which is fairly typical for a UK installation. So with the current going through one side and the other is different by 30 milliamps or more, then the device will switch off. And we've got 2 of them in here, and each one covers 3 of the circuits. So this one here covers these 3 circuits here, and then this one covers those 3 circuits over there. And it's supplied with some miniature circuit breakers. And we've got various ratings here, 40 amp, 32 and a 6, and over here we've got a 32, a 32 and a 6. Typically this would be intended for probably a shower, cooker and some lighting, and then you've got some sockets and another lighting over there. Now the major disadvantage with this style is that although you've got 2 RCDs, it does mean that any fault on one of these 3 circuits here will cause this to trip, and likewise a fault on any of these 3 will cause this to trip. And unfortunately, faults do tend to happen fairly often because things like kettles and irons and whatever, obviously got water in, and if anything goes wrong inside, then that's going to cause a fault to ground or earth, and that's when your thing will trip off. And the problem with this arrangement is that although you may know which set of circuits it's been affected, it doesn't really tell you which of the actual individual circuits it was. So if you've got, say, 2 socket circuits and some lights, it could in fact be any of those 3. And although it keeps sort of half of the house powered, it does mean that a fair amount of your property is going to be disconnected in the event of any kind of fault. The better way of these is to have RCBOs, which is this and this combined, and then you have one for each of the circuits individually, but they don't tend to get fitted that often because of course they cost more. So anyway, let's have a look inside. The lid on this one is just secured with these 1/4 turn screw things. And here we are inside. Now this one, say, comes with these devices in, but of course you can always take them out and change them for other ratings. Normally, say, it's a fairly sort of generic set of ratings, so intended to be useful for the majority of situations. Now when you actually get these in the box, there's a couple of extra pieces which are not shown here. This piece here actually just fits in there, and it's basically a cover so that you're not touching the live pieces of copper at the bottom. And, just clips in there. And the copper bus bar here, which I've already cut into 2 pieces, generally comes as a long strip, and then the idea is you can cut it up to whatever length you want. So in this case we've got 3 on each side, but there's no reason why you couldn't just say put 2 there and 4 here. Of course on the larger units with up to 6 on each side, then there's different combinations you can put in. And the other thing you can do on some of them, which is not particularly practical here, is you can actually use this and put another circuit breaker between the main switch and the first RCD, or put an RCBO in there, and then of course you'd use the spare piece just to link in there. So you've got sort of 3 sections in that case. But really if you're going to the trouble of having 3 sections and some RCBOs, you may as well just ditch the twin RCD arrangement completely and just put RCBOs for the whole lot. Now another reason I don't particularly like this arrangement is because of all this mess of cabling inside, and this is actually how they're supplied. So you've got all these blue and brown wires in here, and of course this is necessary to link to the various devices. Now The usual arrangement with these is your mains power will come in at the top of the main switch here. In this case it's line here on the left and neutral on the right. And so that's just a switch, so obviously on or off. And then at the bottom here we've got the neutral coming out via this blue wire. That goes up to the bar at the top. And then the line comes out on the brown one, and that actually loops around underneath there and comes out the top. And that goes into the top of each of the RCDs, so here and here. And the neutral from the RCDs actually goes via these two here. So it's basically coming in up to there through this bar, and then you've got two wires coming in down off of there, one of which goes to here, and the other one of course goes over here. So basically it's top in for the supply, comes out the bottom, then it ends up going in the top of each of the RCDs here and here. Now assuming the RCD has been switched on, and your main switch is on as well, then the line and neutral will continue through the RCD and come out at the bottom. Now the line comes out on this copper bar, and that in this case goes into the 3 circuit breakers here, and then the neutral comes out at the bottom of here and actually goes up to this bar here, and this is where you connect your neutrals from the circuit wiring. Then the lines will connect to the top of the circuit breakers here. And it's exactly the same thing with the set over this side, so again your power's coming in at the top, and assuming it's on, then your line comes out on the bar here, goes into the bottom of the circuit breakers, circuits are connected at the top, and then the neutral for this one comes out the bottom there via that wire, and that ends up on this bar over here. And the reason there's two separate neutral bars is because any current that goes through here onto these 3 circuits has to actually return via this RCD. Otherwise, of course, you're going to get that imbalance, so one or the other is going to trip, and in some cases both. So for every RCD you need a separate neutral bar there. And this one has the additional terminals over here, so that if you wanted to put a circuit breaker or other device in here directly from the main switch, then that would connect to the 3rd bar at the top there. And for all the circuits, the earth is the bar at the top here, so your incoming earth would connect on the one of the terminals here, and then you've got your numbered connections there for each of the circuits. And if you're going to fit these in, then generally it's the recommended method to actually put these in the same order as they are on the circuit. So you number these sort of 1, 2, 3, 4, 5, 6, and of course connect to the appropriately numbered terminals there as well. And the same for the 2 neutrals, so you'd have sort of 3 there, would go to the first 3 here, and those 3 would go to the 3 there, and obviously if you had one in here, that would connect to those there as well. Now if you're going to fit this type of thing, and so I don't personally like this arrangement, there's a few things to check. The first thing is to make sure that all of these connections are actually tightened, because although they're supplied like this, there's no guarantee that these have actually been tightened properly, or they may have come loose in transit or whatever, so you do need to check that all of these are properly tightened. And of course your circuit wiring obviously would make sure those were tightened as well, likewise for the main incoming power over this side. And just as with the terminals here, you would need to check all of these neutrals at the top, because again there's no guarantee that they're still going to be properly tightened, and also the cables coming at the bottom here and over here. Now the bus bar here, which is just basically a copper strip, as I say, when it's supplied, this actually comes separately in the box, and then it's a question of just cutting it to size. So in this case I've just cut it to 4 pegs on each one, but as you see it just simply drops out the bottom. It's purely held in by the screws of the devices there. And when you actually put this in, it's essential to ensure that at the bottom here you're actually putting the bus bar on the correct side of the grip there. So if I just tighten up this one, you'll see that that piece will pull up against there, and of course the metal needs to be inside there so it actually grips onto it. One thing which is quite easy to do, particularly if the consumer unit's low down near the floor because you can't see it, is to place the copper bar in, and of course if one of them is not actually open properly, then you can actually miss and it will actually go below the bar. And then when you tighten up the other ones, they will pull against it and that will grip on the others there. So you've got a kind of connection here, but it's only because of the fact that the ones on either side are basically just pressing that against there, and that can lead to overheating. And you'll also note in this case that the breaker itself has been pushed forward, so it's not actually in line with the others anymore. So a very easy thing to get wrong, and of course if you're just looking at it from the front like this, for example, and this is sort of low down on the floor, then you wouldn't necessarily notice that that had actually happened. So if taking this out on an existing one, or even putting it on a new one, you do need to make sure that all of these are fully open. and that the bars go into the correct place, even if it means getting a mirror on the floor just to be able to see up there and make sure that the holes are all actually fully opened. Of course, the same thing applies over there. Now, if you wanted to change one of these, say it was the wrong rating or whatever, then they actually just clip onto the metal bar at the back. And it's just a question of putting a screwdriver here to release the clip, and then it just lifts out as a complete unit. So at the top here, that just hooks over the top of the bar, and then the bottom is just secured by the clip, which just again hooks around the base of that. And if the clip is pressed in, you can generally just hook the top on, and then just snap the base over like that, and then that's reasonably well secured in there. And it's the same deal with the other devices as well, the RCD and the main switch. Again, they just clip over the top and the bottom of the bar at the back. On this particular design, and in fact most of them, you can actually remove the bar completely just by loosening the screws here and the one at the other end, and then this whole assembly can just lift out. Of course, that's much easier when it comes to fixing it on the wall. And of course, you can also disconnect all of these wires here if you would like to take the whole assembly out. Of course, if you're doing that, just make sure that they go back in the correct places. Now, in a later episode, of course, we'll look at actually attaching wires to this sort of thing and how to test them. But once you've put the devices in, and of course your additional copper bar would go in there, then it's a question of making sure that all of the connections are properly tightened. And this goes over the front because all of this copper here would be live when the things are actually switched on. So, of course, that's there just as a sort of secondary cover with the warning label on it. Generally, if you're going to take this off, make sure that the switch is actually off before doing so, because say all of this is literally live, so touching that and that's time to kill yourself. Or maybe if the RCD turned off, you probably wouldn't, but in any event, pretty severe shock can be had from all of that. Now the cover on this one, say just slots over there, assuming you've got them lined up correctly. Now, all of these are actually supplied with a whole sheet of labels. Even the very cheap consumer units always come with a whole pile of labels to stick along the bottom, indicating what the circuits are, but sadly it's fairly common to see these installed with no labelling. It's just being lazy, because let's face it, it's not exactly a big deal just to peel off the appropriate label and stick it in the appropriate place. Now, so this consumer unit is actually made of plastic, so this won't be permitted from January, which is only a few weeks away at the time of making this video in November 2015. But nevertheless, the internal arrangement for the metal ones is exactly the same. It's just that the outer case is made of metal. And if you want to fix one of these on the wall, just one other point to note here. This particular style has a rather annoying feature, and it's certainly not the only one that has it by any means. Let's do the lid up there. In that the lid, as you can see here, is actually considerably wider than the base, and that's both true in the width there, and if you have a look at the side there, it's also taller, and it overhangs at both the top and the bottom. Now the problem with this is, if you didn't notice this before you attached it to the wall, it's quite possible you might think, well, this is going up in the corner of the building, for example, or in the corner of the room, and you might place this and then have the wall right up against the side of it, so nice and neat and there's no gap there. But the problem with doing that is you'll fix it on the wall, and then you'll fix all of the cabling in or whatever and spend a considerable amount of time doing that, and then you think you've finished the job and you get the lid, and of course you go to put it on here, and of course you can't get it on because the wall is in the way and you can't actually get the thing lined up. And then, of course, it means undoing a whole lot and dismantling half of what you just did. So always check that the lid is actually going to fit before putting any of the wiring in. Sometimes have a lid which is the same dimension, which is probably better. But sadly, this style of lid where the thing actually overhangs is not uncommon. And so if you've got one of those and you've just spent 3 hours or whatever fitting it on the wall, then unfortunately you're going to spend a few more hours undoing it all and putting it back together. So let's look inside a fairly typical UK consumer unit of the cheap variety sold in DIY shops and the like. But until next time, thanks for watching.